So, okay, it's recording. Thanks, Ilaria. Sharing my screen. Okay. You can see my screen?
Yes.
Okay, so good morning again. I'm Bruno Fies from CSTB. Thank you very much, Ilaria, for this introduction. So today I will present you an overview of the BIM2TWIN project. And then, as said, we will dive into some more technical presentation from Professor André Borrmann about one specific component of our project. And we will have then other webinars to dive into the other services that we have developed in the frame of this project. So as you said, Ilaria, this BIM2TWIN project has started in November 2020. We are approaching now the end of the project, which is April 2024. So in few months now. And well, before it will end, let me introduce you to this project. So BIM2TWIN is about digital twin, of course. It's a digital twin solution to provide awareness for the on-site activities follow-up. So we are focusing really on this specific phase of construction, which is the erection of the building itself. We are a consortium of 17 companies spread among 8 countries, so from Israel to Finland, and we have a balanced consortium, I would say, composed of research centers, universities, technical providers, but also construction companies, mainly in our project. So what were the leading ideas in our project? So the idea, as I already said, was to provide the managers of the on-site activity, is to provide them with an overview of the situation on the site, what is occurring on site, with a specific focus on some aspects due to the skills of our consortium. So we have been focusing on the quality of the work carried out, and when we are talking about quality, we are thinking about is what we have erected well erected and erected on time. This is the notion of quality for us. We also focus on the workers' safety conditions, the use of equipment and the optimization of the use of this equipment. And also we developed a specific service for the prediction for on-site completion and alternative planning in order to be able to react the best way possible to unforeseen events that are happening always on site. And we do that by performing a continuous comparison between what is built, so what we can grab from the situation, what is occurring on site, with what was planned. In terms of architecture, as I said, the main component is the platform, onto which we have developed and plugged different services, focusing each time on different aspects. So in orange, you have this volume control and process monitoring. In yellow, something that looks similar but is not, in fact, it's about surface control and process monitoring. One is focusing on safety control, then equipment optimization, and the last one was about production planning. In order to initiate this platform, we rely mainly on the BIM, coming from the design, so the BIM of the building information model of the project, and the corresponding planning of this project. And to follow up and to gather the status of what was going on site, we rely on acquisition devices and persons in order to feed the services with what I called here hot data coming from the site. And we developed also we developed also a dashboard in order to offer this overview to the managers to recap into a few screens the different KPIs that are monitoring or showing how the site is going on. In terms of technical choices, well, we adopted a distributed architecture, so different components were in fact different services loosely coupled to the platform. It means that for some of them, they have a standalone or self-existence, but they are also able to communicate with the platform. We make heavy use, I would say, of the semantic technologies, and we adopt a linked data approach. One of the important work at the very beginning of the project was to sit around the same table in order to adopt a common and shared language among us and then among the services. So it means that we have been developing a common vocabulary. Then we developed also data models. We picked from existing ontologies what was relevant for us, but we developed also our own vocabulary. And each time the BIM, the building information, was playing a central role in this work. So now, just to re-share with you this image of the platform and its services. So we have been developing different services, different kinds of services. One were more producing information and sending it to the platform, as other ones were doing both, taking information from the platform in order to perform their processes and then send back KPIs or new information back to the platform. And as you can see, for instance, volume control, process monitoring, we have been relying on LiDAR, and we were working on point clouds as raw data in order to make this analysis of the volume control and process monitoring. Surface control and process monitoring was focusing more on surface aspects and defects. So we have been using more images. So it was based on the use of camera in order to detect if the surface of the work was good or was presenting some default cracks and so on. For the equipment optimization, we have been relying on camera and video to track devices, to recognize them, and to detect their trajectories. Safety control was more linked to the platform, taking the situation of the on-site erection at a given instant in time in order to detect if there were a hazardous area in this situation, and calculate how to place guardrails in order to prevent the workers to fail when they are working on the site. And we have also the production planning, which is also taking into account what was going on, what was provided by the other services in order to perform its analysis and propose back some alternative plannings to take into account possible events that occurred on site. We deploy that on our pilot sites. So here I just mentioned 3 of them, but we had more. In fact, we had more. So we have been deploying that for residential office building, mainly in Finland, in Helsinki. In France, it was for a building renovation in Nice. In Spain, it was about the extension of an hospital in Valencia. As said by Ilaria, this webinar is the first one of a series of 5. Each of these webinars will be focusing on a specific service or specific aspect of the project. So you have everything here. I'm not going through it again. This will be shared with you. And I think now it's done for me. I will let you dive into the technical presentation of our platform. It will be done by Professor André Borrmann. So, André, I let you the floor. Maybe I will be back at the end of your presentation in order perhaps to present some lesson learned from the project and continue the discussion and answering the questions, if any. So, André, the floor is yours. Thank you very much.
Thank you very much, Bruno, for the nice introduction. So I now share my screen here. So I hope you can see it. Yes, okay, perfect. So yeah, Bruno already gave you an overview of our digital twin project. In the core of the entire developments, there is a platform, the digital twin construction platform, as we call it. This platform is supposed to manage all the data, all the information that we have about the construction project. Well, it really forms the central component to which all the other developments have been connected. And this is what I would like to show you today. So the platform that we have developed is able to capture, as I said, all relevant information of the construction site. In particular, the as-designed data and the as-planned process data. But on the other hand side, also the as-built data and the as-performed process data. So we always have these different dimensions that we try to capture in the platform, we are able to capture, which means that we have on the one hand side, the process and product dimension. So both is very important and very relevant for the performance of a construction site. But we also have the intent dimension, so what was originally planned. And we have the status dimension, meaning we try to reflect what is currently going on, what is the current status on the construction site. And then we have, of course, the physical and the virtual dimension, but this is clear. Our digital twin tries to be a replica of what is going on in the real world. This is a little example of how you can imagine that's a typical construction site. Lots of things are happening, and it's a big effort to really make sense of what is going on. So what we see here is raw data from a camera in this case, but also we see a first step of processing. In this case, the workers have been detected and parts of the equipment. And well, this is the basis to then provide more higher level information, for example, about the current resources that are used on the construction site, but many, many other applications as well that Bruno has talked about already, like, for example, detecting the current progress of the construction site, but also detecting things like damages and so on. So this is the kind of raw data that we are dealing with, and we try to make higher level information out of it. This brings us to the platform architecture. So in the core of our architecture, we have this blue box here, which is supposed to be the data management core. We use here a product, or not really a product, but a platform that has been developed by Orange. It's called ThingIn, and it's a graph-based platform. In the graph-based platform, we store 3 different types of data. So on the one hand side, we have the raw data. Then we process the raw data into information, and we come back to this later on. And finally, we have the knowledge. All 3 different types of data are managed using a graph-based approach, because Orange is essentially a graph-based digital twin platform. Another important component you see here on the right-hand side, which is the translation and injection module. Here we use data that is available in the form of files to bring it into the platform. So this includes, for example, project intent data. So for example, the BIM models, but also the schedules that might be represented in Excel sheets or something like this, and so on and so forth. And we also have the raw monitoring data, which includes images, videos, point clouds, and so on. We then perform this translation and injection, and we go through a data validation to make sure that the data is of high quality and also implements the data structures that we have defined. Only then we can really bring it into the platform. Of course, we have also an authentication module, which makes sure that only people that are allowed to have access really have access to the platform. What we also have is a BIM2TWIN dashboard. So this is the front end for the end users. In our case, it's the decision makers, the construction managers that need to have a good insight into what is going on. And this dashboard represents the digital twin data, information, and knowledge in a way that can be easily consumed. On the other hand side, we have also the user interface of ThinkIn. This allows us to see the raw data, the raw graph structure that are stored in the platform, and helps us to navigate this kind of information. On top of that, you see here the different services. These services are very important because they provide a lot of additional functionality, like, for example, processing images to higher level information by detecting certain elements in the images, processing point clouds, detecting equipment, and so on. And this is also a very important feature of the platform. It's modular and it can be easily extended by using web APIs. So we have open, well-defined interfaces that allow to connect these services in a quite straightforward manner. Let me come back to this concept of data, information, and knowledge, which is really at the core of our data structures. So it was clear for us from the beginning that we really have to distinguish between these different qualities of data. So on the one hand side, we have really the raw data on the lowest level, which is unprocessed, more or less unprocessed, like, as I said before, images, videos, point clouds, and so on. Then on top, we have information, so information that has been created from processing this data, like, for example, detecting persons in the images, detecting equipment, detecting finished components in the images, and then, well, define a status of a certain component or identifying the number of resources on the construction site. So this is then already higher level information. And from all the information, then we produce knowledge. Knowledge on the one hand side of about the current construction site, but also across different construction sites. This knowledge is represented by so-called KPIs, key performance indicators that we have defined at the beginning of the project. And of course, these key performance indicators are then developed and determined on the basis of the information. For all three levels, we have defined ontologies. So on the lowest level, we have the BIM2TWIN data ontology, which helps us to index and navigate the raw data. So the raw data is stored as binary information. However, we use kind of a library that is represented by this ontology. Then we have the core ontology on top of that, so the digital twin construction core ontology, which really represents the most important part of the entire platform, because here we structure all the information we have with respect to the design building, as built construction, but also with respect to processes. I come back to this later on. And on top again, we have a rather small ontology, which helps us to define these KPIs. So let's have a closer look on the core ontology and the data model that is lying behind it. So we have followed the concept of a modularized structure. So we have really a core model, and then we have certain extensions, for example, with respect to quality, safety, process optimization, and so on. We have then also used existing standards wherever possible to define these models. So you see here a number of available ontologies and other data formats that have been used and integrated So to reinvent the wheel with respect to these data models. In overall, we have followed an UML-based development process. So we have defined the class diagrams first in UML. We have refined them, discussed them, and so on. And then when we were finished, more or less, then we translated this into an ontology. This helped us to implement a so-called linked data approach, where we use semantic web technologies. So the ontologies have been defined all the web ontology language, and the instances are represented by RDF. So we have RDF instance graphs that represent the concrete project that we have at hand. If we have a really close look now at the core ontology, you see here the UML diagram. For us, it was really important to have clearly defined the as-planned processes and as-performed processes. So this was really here the core of the developments. And you see on the as-planned side that we have elements like task, activity, and work package. And on the as-performed side, we have elements like action, operation, and construction. And of course, these two elements are supposed to be linked if this is possible. But sometimes, well, you know, construction sites are not as planned. Then we might have a difference. But still, with this flexibility that we have here, we can always capture the as-performed processes, which is very relevant for the overall approach that we have here. So the core ontology, and I cannot go into much detail here today because we have kind of limited time available. You can see this core ontology because we have released it and published it. You find the URL here. We will also later copy it into the chat so you can directly open it. It's really publicly available, so everyone in the entire world can have a look on the ontology. We made it available in a way that it can be consumed by humans, but also by machines, by services who can then navigate this ontology and explore this ontology. We have, for the humans, we have a very detailed explanation of all the different classes, attributes, and relationships. So I really invite you to have a closer look on the ontology. Then these ontologies are the data structures, and of course we have to manage the actual data. And to this end, our project partner Orange provided the Think in the Future platform. In short, ThinkIn. This is a very powerful graph-based platform that we could use here. Of course, we had to adapt it and customize it. Nevertheless, it provided already a very good basis. And to give you some insight into how this looks, we see here another movie from the platform. So it represents everything as a graph. And we have here now one node. You see the node information on the right-hand side, which represents the entire building. And from this node, we can use all the relationships that have been defined there to jump to one of the stories. From the stories, we can jump to one of the elements being there, which in this case is a wall, and we can query all kinds of information about this wall, like for example the status. Has it been built already, or is it still under construction? Does it have damages? Are the damages maybe improved and cleared, or does this element have any kind of problems? So this is the really core of the graph-based platform. As I said before, it's super important for us to have a modular structure, so to be able to extend this platform in an easy way. And luckily, Think in the Future provides a web APIs, REST API, that you can easily use and connect all kinds of external services to this platform. So this, as I said, also had to be refined and improved. Nevertheless, now it's really in a good status, so we can show that also the other work packages have been developing services that on the one hand side provide data to the platform, and on the other hand side are able to also query information from the platform. A typical example of such a service would be, as I said before, the investigation of the different movies and pictures to find, for example, certain elements, and then provide back information about the completion of the individual building components. We have tested and validated this platform with the help of our pilot sites. Bruno talked about the pilot sites already. We will not go into detail here because there's another webinar planned on specifically these pilot sites. Nevertheless, I will quickly talk about how we brought the data from the pilot sites into the platform. So a certain number of pre-processing steps are required. So typically, IFC files are provided, which is good. So this is the design intent, the as designed building model. However, we found out that often the IFC files are not perfect, so we had to correct them. For example, some of the objects were incorrectly classified. We had to improve that. There were overlapping elements. There are also elements that are assigned to the incorrect story, so these kind of things had to be corrected. We also merged the different domain-specific IFC models, like structural and architectural models, into one big model, because then we could more easily navigate that. And of course, we had also very small elements, very specific elements that were not required for the investigations that we wanted to do in our project, so we had to remove them. Yeah, typically, these are the required setup steps when you have a new project that you would like to bring into the BIM2TWIN platform. So first of all, you use the IFC injection module to bring in the data about the as-designed building model. So in this case, all the IFC elements will be transformed into graph elements, at least the most important ones. And we also store the geometry. However, the geometry is not represented by graphs, because this would be too big in terms of graphs. And also, we do not require to really model each and every triangle in the graph. But instead, we use a big binary object represented by PLY files. So this is a generic approach to represent geometry. And we make use of that here because it's also more efficient and more performant. We then also injected the schedule data. Very often this is available in the form of Excel spreadsheets. Of course, they have to be analyzed. We have to link them also, the individual tasks in the schedules, with the individual elements of the building model. This has to be done. And then we can also, if this is available, have information about resources like number of human workers on the site, availability of equipment like cranes, concrete mixers, and so on. If this is available, then we can also extend our information in this regard. Yeah, here's one concrete example, one of the pilot sites located in Finland, in Postiaukio. This is a residential building, as you can see here, well, medium size, I would say. Again, I will not go into the details of this project because this will be covered later on. We had quite a good IFC model here. Nevertheless, we had to slightly correct it and improve it, but we could directly bring it into the platform. And we had also an Excel file, Excel spreadsheet representing the different tasks. However, it wasn't finished, so we needed some help from our project partner to understand what these tasks are about, and then also provide the links with the respective IFC models. In the end, we could really successfully evaluate our platform, having both on the one hand side the as designed information, as planned information that we see here, but then also data from the construction sites, from images, point clouds, and so on. But as I said, this will be covered in detail in one of the next webinars. So now this is kind of the core aspect of our data management platform. But of course, we also need to visualize this information for the end users. End users, in our case, are decision makers, are the construction managers on the site, or construction managers in, well, let's say, the central location of the construction companies. To this end, we developed this dashboard. The dashboard is kind of the front end for our digital twin platform. It has different visualization capacities, like including a very general overview where we see, for example, the current status of the project, how much is completed, how many tasks are going on, and so on. Then we have also a chart visualization where you see the development of the certain KPIs over time. Then we have a tabular view showing you really the values, the numbers, the hard numbers. And what might be most important, we also have, of course, a 3D view where we use the BIM model as basis for representing more information about the current status of the construction site. And again, I have a small movie about this front end here. So it's running in a browser, so everyone can easily use it. We see here the KPIs on the left-hand side, like cycle time variability. We see how this has been developed over time, which provides a very good insight about when the construction site was very productive and very performant and when not so much. Good basis for further detailed analysis. We see all the detailed information in terms of numbers, precise numbers. And then we can also see here the 3D visualization, which is kind of the core of our front end here, which has a number of different capacities. For example, you can select individual components and you get all the information about the components in terms of completion status. But also if we have damages or defects at these elements, this will be directly represented. So the raw data, the images we stored about these individual objects is also accessible through this 3D web interface. It has many more features, but I can only talk about this briefly here. Like, for example, we can also see the safety elements that have been installed and then check if the safety is really provided. Yeah, so again, some slides on this, but actually I talked about this already in detail. So we have here the KPIs, the key performance indicators, which have been defined at the beginning of the project. You see a number of them here on the left-hand side. So for example, in terms of performance or execution performance, we have cycle time, throughput, work in progress, and so on and so forth. And we have also KPIs related to the quality of the ongoing works. So really high level information that has been processed and determined from the lower level information. Here we see how the 3D view can be used to also get information about the progress. We didn't really see this in the movie, but you can also select all the elements that have been finished already. You can show the elements that have been that are delayed, are not yet finished as originally planned, and you can also filter all the elements that have defects to get a clear overview where we have problems on the construction site. And this is also something that I said already. We have also the option to combine images from damages, for example, and not only this, but also this kind of higher level information that has been created using AI algorithms as one of the services of the platform, where we have something like the timestamp, but we also have the classifications. So in this case, this is called honeycombing. We have the total defect area, and we can also assess how critical this defect is. So all this information is stored in the platform, but it's also provided to the end users using this web interface, this front end dashboard. So this brings me already to the end of this quick presentation. It was, as Ilaria said, over almost 4 years of development. So we don't have the time here to go in each and every detail. Nevertheless, a quick summary. So we have talked about this BIM2TWIN platform. It's a very capable data management platform. It was important for us to have really these 3 different levels of data: the raw data, the information, and the knowledge. We define for each of the different layers very well-defined data structures, which are expressed using ontologies. To really manage and maintain the data, we use Orange ThinkIn, which is a very powerful graph platform that can be accessed via REST APIs. So you see all the arrows here are essentially accessing the decentral platform through an REST API, which makes the entire system very modular. And this is especially important because we have all the different services that provide certain functionality like image processing and so on, and can be easily attached and connected with the platform. And we talked about the dashboard in detail. So this is really the basis then for the decision makers to make sense of all the information and knowledge that we have provided. All right, that's it from my side. And if I'm not mistaken, we now have a bit of time for questions.
Exactly. Thanks a lot, Professor Borrmann. Yeah, now the floor is open. If you have any questions, you can ask them directly, write them in the chat, or write them to me, and I will read them to everyone. So
it seems that everything is super clear.
No, there is one question. From Singh Abhishek, thank you, Professor Borrmann, for the insightful presentation. Request you to elaborate on how the data from site flows to the developed framework. And the follow-up is how this data is registered upon receiving from site.
Yes, very good question. So maybe I go back to the general architecture. So we have here exactly this box, raw monitoring data, and essentially this is exactly how we capture the data from the site. So we have different monitoring techniques. This includes, on the one hand side, the images like the movie we have seen in the beginning from the crane cameras, but we also use other devices like laser scanners, and we have also data from the construction managers, like manual data. Especially for the raw monitoring data, like for example the images and the point clouds, we provide them in the platform. In this case, we speak about the data level. So this is more or less untouched data. So we will really store all the images that we get. However, as I said before, in a quite binary form. So this is not using really the graph structures. In the graph nodes, we simply store meta information about who has provided this data at which point of time, and so on. Then we have these different services, and one of the services, and this will be presented directly in the next webinar, is able to process these images and identify, for example, the number of workers on site. And then this is brought back to the platform. And in this case, we give this information into the information part, where we then have information, for example, about the resources, but maybe what is also very important, the detection of elements. So this is one of the other services that we have developed in the BIM2TWIN project, that we are able to detect, for example, individual columns, individual walls, and so on, and then know, okay, this element is really finished, it is done, and can provide this information then to the process part of our core ontology. So this is the typical flow of information here. We have the raw monitoring data coming into the platform, being stored to a quite big extent, and then being processed again by other services that in return provide higher level information. So yeah, that's the basic principle here.
Perfect. We have another question, which I would couple with another one I received in private, which is, so the question from Afner Buro is this just science or will it lead to a usable product? And the other question is, will the platform be made commercially available?
Yes, both are very relevant questions. So of course, it's a research project. So of course it's science, so to say. I would not say only science, because science is very often the basis for innovative products. The decision to which extent this will be made a product is currently being assessed by the different industry partners. So I'm from the Technical University of Munich, so we are not creating commercial products. We don't have the resources for that. But our project partners, like for example Orange, they have already developed this platform, and one of the options is that they turn it into commercial product. But of course, this is their decision. They have to assess the market. They have to assess the developments that are still required to make this a robust and really distributable software product. But this is definitely one of the options that this will become available. Yeah.
Thank you. And we have a third question. In terms of the data model, do you think that it can be used in other domains, such as maintenance, with domain-specific KPIs?
Yes, very, very good point. I mean, in maintenance, you might have additional requirements. Like, for example, you need to know the status of certain equipment. But because we have left many aspects very generic, so the status of an equipment, whether it's failed and needs repair and these kind of things, can also be brought into the platform. Maybe here and there, some extensions would be necessary, but because it's so flexible, these kind of extensions should be easily being performed. So yes, I would say the platform can be continued, and actually that's also one of the things that we propose in our project, to not only use the platform throughout the construction, but use all the information that we have about defects and so on, then also through the entire life cycle. So we didn't have the focus on the maintenance aspect, but I would say yes, that's possible.
Mm-hmm. Yes, well, perhaps to continue with that, and the two last questions were in fact a good transition towards some lessons we learned from the project, and I have a slide about that, and maybe we can continue on that, because yes, I think this totally fits for maintenance, but it's not focusing, the maintenance is not focusing on the on-site activity phase. It's more on exploitation, so later in the life cycle of the building. So if I share my screen again. Okay. If I continue, yes. This is just as a kind of conclusion, or just to start to another series of questions. It's just to recap briefly the lessons we learned and the next step we were thinking about after this almost 4 years developing this BIM2TWIN solution. So first of all, as André mentioned it several times, any digital approach requires data to be well structured and coordinated. So we have been suffering at the beginning to understand each other. We spend also a lot of effort in order to adapt the initial data, the BIM files, the planning we received, in order to be sure they have the right level quality, I would say, before injecting it in our solution. We spend also a lot of time to coordinate the information that was present in the BIM with the information present in the plannings, how to make the link between a column that is described in a BIM with a task corresponding to the erection of this column in the planning, if they have not the same ID, the same identification. So it was based on human reasoning, but how to proceed to base that on computing only. So it requires, again, coordination and a structured approach for that. Few words about then the maturity of the technologies we use. So as said and as demonstrated by André, linked data approach was the right choice and is mature enough for the platform. We are very happy with this technology. When we are talking about the acquisition device, for instance, well, it was something that has evolved over the duration of the project very much. So it's rapidly evolving. We were expecting more accuracy from some devices. For instance, the one that is providing point clouds. But there is always a balance. If you would like to be more accurate, then you need more data, and the volume of data to be processed can become also too big. So it's a balance. And for the moment, well, we put the cursor at a level that where we were able to process the data, but the accuracy at the end was around the centimeter, where we were expecting the millimeter. But it's something that is evolving very rapidly. In terms of, well, future tracks, future research tracks, well, as I said, we were focusing on the on-site activities. So in the life cycle, it's how to facilitate the deployment of such solution easily. So how to facilitate from the design to the execution transfer. This is something that has to be envisaged in order to lower the cost of such a solution to be deployed. And then at the end of the erection, when we are starting really the operation, the exploitation of the building, how to make it as efficient as possible. So I think there could be already some links to be done with the digital logbook. Or how we can also link what we have done with something more active around the safety for the workers and equipment, and then how we can think about off-the-shelf offering. In order, again, to facilitate the deployment of such tools for the follow-up of on-site activities that may be quite quick in time. I mean, we have seen with our construction sites, sometimes it was a question of 3 months, 6 months. So it's very quick. And if we want to have this digital twin offering for them, it must be deployed very quickly and at a reasonable amount of money. Well, that's what we learned and what I would like to share with you. And now I think this is it for me, and it's time for other questions, if any.
Yeah, actually, there is another one. That is, was there integration of existing building-related ontologies like brick into the DTC ontology?
Yes, and maybe I would like to invite also Jonas to talk about this in detail. So we have indeed done an intense investigation with respect to existing ontologies. In the end, we decided for a number of ontologies to base our work on. This included, for example, the BOT ontology, the building topology ontology, but also certain elements of the IFC all ontology. In both cases, we did not use the full ontology, but of course that's not necessary because you can also kind of cherry pick those elements that are relevant for us. Yeah, maybe Jonas can say more about this.
Yeah, I think it already summarized it quite well. So yes, the BOT ontology is the most important one. Then also the building element ontology is quite important for us. So this is kind of like using the building element parts of the IFCL ontology. And other than that, we use some kind of like non-construction specific ontologies, for example, for different types of units and time-related aspects, and so on and so forth.
Bruno, maybe you can show the slide again where you have the next webinars, because that might be interesting for our viewers today.
Okay.
Yeah, so already next week we have the next webinar.
Yes.
Which is done on progress monitoring and quality control. So one of the services that we have seen today that is using data from the platform, but also providing important information back to the platform. Then we have the demo pilot projects, the pilot projects we have talked about briefly today already. It will be an entire hour only on the pilot projects. And then we have occupational safety and health and equipment optimization at the 26th of March and production planning at 1st of April. So it's now really a series of webinars where we go into more detail about the individual services, essentially.
Yep.
Exactly. I have copied and pasted in the chat also the link to register to the next webinars. If there are further questions, doubts, curiosities, please feel free to ask them. If not, we will, like in short, we will close the webinar.
Yeah, and you're also invited to send us emails, so you can easily find our emails. And if you have a very specific question, you are very much invited to send us emails.
Okay, so thank you very much. I think that we can close down this this webinar. Some of us will be back next week. In the meantime, Ilaria, the recording of this session will be available on our website.
Exactly,
Perfect.
and also on our YouTube channel. But all of you who did register for the webinar, you will receive an email with the link to the recording.
Perfect.
Okay, then thank you very much for the attention, and hope to see you all at the next webinar.
Thank you very much.
Bye-bye.
Bye.